Okay, these are the Algebra 2 6.7 notes. So the first thing we're going to do is we're going to figure out how to tell when something is linear or exponential or a different type of function. So the first thing we do is we look at the pattern of the x's and the y's. So on these x's, as you can see, each time the x's are increasing by 1. And it doesn't really matter what the x's are doing, they just have to have a constant change. So they can't like increase by 1, then by 3s, then by 10s. They have to either be like +1 the whole time or up by 2s the whole time, just consistent. Okay, the y's are where you really find out what's happening. So you look at the pattern of the y values. On this one, I can tell they are multiplying by 2. If you look at that, you're like, okay, these are multiplying by 2 every single time. Now they have to work the entire way doing the same thing. So if, like this one's really obvious, but if it wasn't obvious, one way you can tell is you take the second y value divided by the y value right before it. So 1 divided by 0.5. Then you try the next set. You take the third y value, which is 2, divided by the y value right before it. Then you take the fourth y value, which is 4, divided by the y value right before it is 2, and so on. You take each y value and divide by the y value that came before it. And if you notice, these are all 2's, and that tells me it's multiplying by 2, which I know is obvious here, but if it was something like multiplying by 3/4, I might not know that in my head, so it's good to have a strategy. All right, so if you have a set of numbers and they are being multiplied through, all the y values are being multiplied by a common factor, then what that tells us is that it is exponential. So the y values are being multiplied by a common factor. Then it is exponential. That means they're multiplied by the same number over and over. Okay, now look at this one. Once again, the x values, if you look, they're going up by 2. And like I said, it doesn't matter what they're doing. They just have to be consistent across the table. So these are going by 2. So we're good there. So now the y values is where you find out what's happening. So if I try what I had just showed you on my calculator, and I do the second y value divided by the one right before it. So, oops, sorry, 8 divided by, make sure you use negative, not minus. That's -8. Now do the next one, do 7 divided by 8. So right there, you're not getting the same number at all right here. And so you know that these are not going to be a common ratio. And so that means they're not multiplied by the same factor across. And so you're definitely not exponential. So what you do now is you do what's called common differences, which we have done before. We did them back with our quadratic unit. It's the first time we saw them, but we've seen them again since then with cubics. So common differences is where you subtract, you do the second number, which is 8, minus the y value right before it. So 8 minus -1, that makes 9. All right, the 7 minus the y value right before it. That's -1. 2 minus, you got to do it in this order, the 7 is -5. That means it's going down by 5. And then -1 minus the 2. 4 minus -1. And 23 minus 4. Okay, so what you just found here, these are called the first differences. Difference means subtract. And if these were all the same, that would tell you it's a degree of 1, which would mean it's linear. Since they're not the same, you do it again, you find the second difference. Now, I'm not going to show the steps every single time. You're taking the y value on the right minus the one just before it. So I get -10. I'll show you one more, but then we're just going to start doing them. -5 minus -1. And so that makes -4. And then -3 minus -5, that's going to make us 2. 5 minus -3 is 8. 19 minus 5 is 14. Now, these are called your second differences. It's the second time you did it. If these were the same, so like all the same number, doesn't matter what number, but they were a constant number, like they were all 5s, then you would know that it was the second difference, and that would tell you it's a degree of 2, which means quadratic. But they're not the same, so you do it again. So the third difference, same pattern, just doing it a third time. -4 minus -10. That's 6. 2 minus negative 4. That's 6. 8 minus 2 is 6. And 14 minus 8 is 6. Okay, so this is the third time we did it, so it's called the third differences. And so that means that if they're all constant, because see, they're all 6, so they're all the same number, it tells you that the third differences means that it has a degree of 3. Third difference, degree of 3. And that means something with a degree of 3 is a cubic function. And you could keep going if you needed to. Typically, we'll find them in the first, second, or third difference, but you could go on and continue to find it. Okay, so let's look at this. Write an equation whose graph passes through these points. We learned to write equations back in Algebra 1 for this type, but when we did it, we were always given the y-intercept. And so on these, we are not necessarily given the y-intercept. So how we're going to do them. Keep in mind that in each of these points, you have an x and you have a y. So this is the general form right here for the exponential. So plug in the x and the y. So if I plug y is 6, a, b to the x is 1. And then for this other point, y is 54, and then equals a, b to the third, because x is 3. So all I did was I plugged in my x here and my y here, and I made 2 equations. All right, from those 2 equations, you're going to use substitution to actually find it. So I'm going to take this equation right here, and I'm going to get a by itself. So if I divide by b to the 1 is just b, I get 6 divided by b equals a. All I did was rearrange it. Okay, so what we're going to do is we're going to take this 6 divided by b, and we're going to substitute it in for the other equation for a, because it's what a equals, that's why it's okay. So we're plugging it in there. So we have 54 equals, and instead of a, we have 6 over b times b cubed. Okay, so that was us just substituting in. All right, so if we simplify that, 6b cubed divided by b. So remember, you subtract your exponents, and so you get 6b squared, because b cubed over b is b squared. All right, now go ahead and solve this. The first thing I'm going to do is I'm going to divide by 6. So I get 9 equals b squared. Then I'm going to square root both sides. Now the square root of 9 is 3 and negative 3, but your b value always has to be positive, so you just use the positive one. Okay, so once you know your b value, you're almost done. Here's your equation for a right here. It says a equals 6 divided by b. So that tells me a is 6 divided by 3, which is 2. So if a is 2 and if b is 3, and you have this format, then you know y equals a is 2, b is 3, to the x. Okay, let's look real quick down here on the self-assessment. Let's try like at least one of these real quick. Okay, so just super fast, they give you the points, and so you're going to label them x and y. So I'm going to have 12 equals ab squared. And then this one, same thing. I'm going to have 24 equals ab cubed. Now, I always use the one with the smaller power, so the one on the left. I'm going to solve it and get a by itself. So a is 12 over b squared. All right, so what you do is now you're going to substitute this in for a because it equals a. So you have 24, and then instead of a, you have 12 over b squared, and then times b cubed. All right, so the b cubed over b squared is just b. Remember that when it's b cubed over b squared, you subtract the exponents and you just get b. So divide by 12. All right, and I get b equals 2. Okay. So if we go ahead and then we know that b equals 2, we know that a is 12 over b squared. So 12 over 4, which is 3. So remember that you're plugging in a, b to the x. So 3 times 2 to the x. Okay, go ahead and try b. I'm going to pause the video and finish it real quick. So pause the video and try b. It's the same stuff. I'd say this is the harder part of what we're doing today. Okay, so just to show you what I did, I wrote my two equations. I solved the equation with the smaller power for a, so a is 2 over b. I substitute that into the other equation. So I have 32 equals, instead of a, I have 2 over b times b cubed. That b cubed over b simplifies to b squared. Divide both sides by 2, and then square root, choosing only the positive number. That's b. Once you know b is 4, plug it back into this equation. 2 over 4 is 1/2, and here's your equation. Okay, so we are actually going to skip ahead. Example 3, 4, and 5 all relate. We're actually going to do on 5, it says, use a graphing calculator to find an exponential model for this data. So that's what I really want you to learn, is how to use the graphing calculator to do it. So what you're going to do is you're going to take your graphing calculator, you're going to press Stat, hit Enter on Edit, and then to clear the list, go up to where it's on L2 and hit Clear Enter. Go up to where the cursor's on L1 and hit Clear Enter. Okay, I'm going to pause this video while I type in the X values into list 1 and the Y values in list 2. You should do the same. Okay, so from here, what I'm going to do, keep in mind that I'm actually on example 5. I'm just using the data from here, and it specifically said exponential. So do Stat, go over to Calc. This is where we find all of these things, but you want to choose the one that says exponential, which is this one on 0. Hit Enter. Go down to Calculate, hit Enter. So here's my A value, 163 point, let's just call it 73, and my B value is 1.08. So I have y equals 163.73 times 1.08 to the x. So, and then if I want to know, like I said, this on example 5, the specific wording asks you to do this with a graphing calculator. It also says predict the number of visitors in 2020. Keep in mind, this says the years after 1990 is X. So 2020 is 30 years after 1990. So you're going to plug in 30 into a graphing calculator. Well, at this point, it doesn't have to graph. And it's about 1,648 visitors. So here's your equation, and there's your estimate. And hold on one second. I'm going to pause the video while I write out the steps, and I'll let you copy them down. All right, so here's each button I press to do this. So anytime you see it in kind of the circle here, I mean that I'm pressing a specific button. And you can always watch this part of the video again to see how we did that. And when you do that is when it specifically says, like it said in example 5, to use a graphing calculator or use technology to find an exponential model. You're like, okay, that's that thing in the graphing calculator. We've now done it with linear, quadratic, cubic, quartic, and exponential data in this class.